Alright, so let's look at some graphs. Alright, so the question here is, does this thing have an Euler cycle? And hopefully, after looking at the last video, you know the answer is no. The reason being, lots of odd degree vertices. Okay, so if you were delivering mail or picking up trash or something to this, this sort of street layout, you couldn't visit every street once and only once. You would have to backtrack. In fact, the more odd degree vertices you have, the more backtracking you have to do. And the way this actually works out in practice, this is something that doesn't appear in the book, but it's important to note, is that just because you can't do an Euler cycle doesn't mean they stop running the mail or stop picking up trash or saying, okay, we just can't do your streaks, can't fit it in. No, they still try to do it. They try to do it in some minimal way possible. And there's this process called Eulerization. So take note, this original graph does not have an Euler cycle, but we can add edges to it to Eulerize. All right, so in the last example, the last video, I did a warm-up example, so to speak, and I had these diagonals going through some of these, and that actually fixed these odd degree vertices into even ones. All right, but as this goes way back to grad school, I remember me and a friend were talking about the process, and I suggested just direct connections as being kind of the optimal way of doing that. And they're like, no, in general, you can't just drive across people's yards. So the process of Eulerization should use the original edge structure. And what we do is we add multiple edges. Okay, so what I do is I can double these edges. And my actual sort of algorithm is I connect together odd degree vertices. Okay. All right, now, if I did this at all four corners, that would actually be pretty efficient. There's also inefficient ways of doing this too. So I'm just doing like an inefficient. We know this is probably a bad idea, right? Do that one, and then maybe do that one, and then maybe I can do some really bad. Let me go double that one, that one, that one. Okay, you can go through and you can do your own versions. And you can see I definitely made some bad choices by adding on this main edge. This has an Euler cycle. It's just an excessive amount of backtracking. Of course, you have to use these. Once you use up one edge, that leaves the other, and so on. All right, so there's this idea of optimal Eulerization. And you should start with understanding Eulerization to begin with. And then, so that's just adding on extra multiple edges, which actually reflect future backtracking that you're going to have to use. And then the optimal version just tries to do this with as few edges as possible. If your edges have distances on them, then this would include that, and typically you'd want to add as little distance as possible. As it stands, though, every edge here is considered about equal to every other, unless you tell us otherwise, right? So that's how this particular one works. But in general, you can use this process, or what you can do is something like this. So let me use the same example that I know is going to fail to have an Euler cycle because it has odd degree vertices. Sorry, if I moved the marker too fast. Kind of see this kind of play out in practice without adding extra edges. Use another color. All right. Let's go through and you can see, okay, once I get up here, I can't do that, so I have to add on an extra edge. Right, you can definitely play this sort of doodle game if you want. Let's see, let me go that way, that way. And it feels like this is really, really cheating. It's not that exactly that you're cheating. The thing is, you're just doing a bad job, right? So you're doing backtracking. And sometimes there's a non-zero amount of backtracking that you have to do. And so this is one reason why it's better to Eulerize first and then do this game second. That way you're constrained to knowing that whether or not you're doing too much or too little. All right, so feel free to play with this game a bit. See if you can Eulerize some graphs. Right, make sure you start with a graph that does not have an Euler cycle. It needs to have some odd degree vertices, and you can play with this, this concept a bit. All right, so we do have more to say about this, and we're going to start talking about Hamilton stuff. So I'll see y'all on the next video.